In this video we will review acid nomenclature. The first thing we have to remember about acids is they contain the H plus ion. They contain hydrogen as a positive ion. So whenever we see something that starts with hydrogen, we're going to know that it's an acid because it has to have an H plus ion and an anion to go with it to balance the charges. So it could be H plus and Cl minus, which would become HCl, which is our hydrochloric acid. It could also be H plus and one of our polyatomic ions, like sulfate, which is a 2 minus charge, and get H2SO4 when we cross our charges, and that's sulfuric acid. Remember, when we're writing formulas for acids, we treat them like ionic compounds because hydrogens act like a positive cation, just like metals. Hydrogen takes the place of a metal. Where you would normally see a metal in an ionic compound, we now have hydrogen, so we would cross the charges, and that's where the two hydrogens come from, because we have to balance those charges. So we had two types of acids that we used for our naming system. We had binary acids, like hydrochloric acid, the HCl, and we had oxyacids, like our sulfuric acid. Binary acids, like the name suggests, with bi meaning two, has two elements, H plus and an anion, which is a negative ion. So H plus and one other atom, which is an anion. Oxyacids, like the name suggests, have oxygen included. So it's going to be H plus and one of our polyatomic ions that has oxygen in it. So we're going to have more than just hydrogen and one other atom. We're going to have hydrogen, another atom, and oxygen. And since they're different types of acids, we name them very differently. So if we have a binary acid, like HCl, we name it with the prefix hydro. Then we get the stem of the element name. And we add ic and then acid to the end. So for chlorine, for HCl, chlorine, our stem is chlor. So we have hydro, chlor, add the ic, acid, and we get hydrochloric acid. If we have HBr, same thing, we get hydro, bromine becomes bro, mic, acid, so hydrobromic acid. The only one that's really different from the naming is sulfur. So when we have H plus and sulfur, sulfur's in group 6, so it wants to gain 2 electrons. It has 6 valence electrons, it wants to gain 2. Gaining 2 negative electrons gives it a 2 minus charge. If we cross those charges, we get H2S. And to name this, since it's a binary acid, we do hydro, and for sulfur, instead of just using the stem, we use the full name, simply because it sounds better. So we get hydrosulfuric acid instead of hydrosulfic acid. So for all of these, we do hydro, element stem, or in sulfur's case, the full element name, ic, and then acid. If we were going the other way, we would look at it and say, okay, I have the name hydrochloric acid, acid means H plus is involved, hydro means it's one other element, chlor means that other element is chlorine, Chlorine's in group 7, so it wants one more electron, which gives it a -1 charge. Across the charges, it's 1 to 1, you get HCl. Hydrosulfuric acid. Acid tells me there's H+. Hydro tells me there's one other element. Sulfur tells me that element's sulfur, so I put S. I look on the periodic table, sulfur's in group 6, meaning it needs 2 more electrons, meaning it has a -2 charge. Gaining 2 negative electrons gives it a -2 charge. Across those charges, you get H2S. And that's how you write formulas for binary acids. Now we'll go back and look at oxyacids. So we said oxyacids was H+ in the polyatomic ion that contains oxygen. The way we name these would be, we do not use hydro. Instead, we take the name of the polyatomic ion, and if we look at our polyatomic ions, we see that any of them with oxygen in them end in either 2 suffixes, either A, TE, ate, or ite. So when we look at naming, we take the name of the polyatomic ion. If it has an ending of ate, we change it to ic. If it has an ending of ite, we change it to us. In the last step, we add acid to the end of the name. So one of our polyatomic ions was SO4 2-, mixed with an H+, we'd get H2SO4. So to name that, we have to look up what is SO4 2-. SO4 2- is sulfate. So we write sulfate. Again, sulfur is a weird one. Instead of just getting rid of the ATA ending and adding IC, we use the whole word sulfur. So we go sulfur. Since it's ATE, it becomes ic, and add acid. So we get sulfuric acid. Notice it's very different, sulfuric acid, from hydrosulfuric acid. Hydrosulfuric acid does not have the 4 oxygens that sulfuric acid has. It's a very important difference, and that's why we have to have the 2 different naming systems. Another example, HNO3. We look up NO3. We find NO3 is nitrate. So nitrate, keep the nit, and instead of trait, we get tric, and we get nitric acid. And if I change one number here and make this HNO2, based on our polyatomic ion list, NO2 1- is nitrite, and that's where we make use of the OUS ending. And this would be nitrous acid. So each polyatomic ion will be named in this form. Like we said before, sulfur is an exception that we use the whole name sulfur. The other exception for polyatomic ions is phosphorus, where if we have phosphate, which is PO4 3-, when it's here as an acid, instead of being phosphate turned into phosphic, it becomes phosphoric acid. But the changing of the ATE to the IC and adding acid to the end is the same. So if we want to go the other way, we're given a name like chloric acid. Chloric, ic comes from 8. Since there's no hydro, we know it's a polyatomic ion. so it becomes 8. So we're looking for the chlorate ion mixed with acid, which means there's an H plus in the chlorate ion. So we look up chlorate. Chlorate is ClO3 minus. So we have H plus and ClO3 minus, O3 with a -1 charge. Cross that and we get HClO3. Now we'll notice with chlorine and with all of the halogens, as we have this note at the bottom saying it's the same for bromine and iodine, we have 4 different options, not just adenite, but 2 other options. We have hypochlorite and perchlorate. So to make a difference between perchlorate and chlorate, we leave the prefix per on it when we change it to an acid. So an acid with perchlorate would be perchloric acid. An acid with hypochlorite would be hypochlorous acid. So we keep those prefixes when we write it. Same thing if we have bromine in there instead of chlorine, it'd be hypobromous acid instead of hypochlorous acid, or perbromic acid versus bromic acid. We will continue more examples of these in class, but those are the basic rules for naming and writing formulas for acids.